Good morning, everyone. My name is Asik Yusuf. Today we are going to see about the quantum cryptography, and it is one part of the cybersecurity and the cryptography subjects. And quantum cryptography, the future of cybersecurity. Explore the evolution potential of quantum cryptography, a groundbreaking field of the principle of quantum mechanism to the levels of digital securities. And what is quantum cryptography? It means it is consists of the three types or three levels, and it is called physics. But it is not contains the math. And second level is quantum particles, and third level is based on deductions. And in the quantum particles, it will be not like by using the physics, and it is based on the encode and transmit cryptographic keys by using the photons. And it is a harmless and unique properties to individual quantum particles. And the cryptography challenge, the traditional cryptography and quantum thread, they are the two main problems in the cryptography. And in the traditional cryptography, it will be relates on the mathematical complexity like RSA and AES algorithm to secure information through computational difficulties. In the quantum threads, the quantum computers can break current encryption methods, rendering traditional security absolute. And the solution of these two major problems is quantum cryptography is used the quantum mechanism principle of theoretically unbreakable security. And quantum thread is yet like encryptions, mathematical foundations, like imminent observations. These are the threads of real quantums, and it is one of the major part of the cybersecurity. And in the encryption, quantum computer possess the computational power to break today's strongest encryption algorithms in minutes. And also it will be a security of sensitive data worldwide. Mathematical foundations like traditional cryptography relies on complex mathematical problems that are easily solvable, and quantum mechanism rendering current security protocols absolute. Why quantum cryptography matters, like future proof of securities, unhackable by designs, protecting sensitive data. And it will like one of the major matters of the quantum cryptography, like based on the securities of our data. And future proof security, it will be classified as a mathematical problems or a classical encryption, and like factorial large numbers which are travel for powerful quantum computers can and unhackable by designs, like due to the principle of quantum uncertainty, any attempt to observe quantum data alerts it, making quantum cryptography theoretically unhackable, protecting sensitive data. Like it provides the essential shield for the world's most sensitive data, ensuring that governments, financial and personal information also. How quantum cryptography works, like photon generation, transmission, receiving measurements, and deductions and key agreements. And for the further slides, we can briefly see about this. Quantum keys in actions, like unbreakable encryptions, real-time alerts, foundation for QKD networks. Once generated in the unbreakable encryptions, Once generated, the quantum keys are enable encryptions that is theoretically unbreakable. Even a quantum computers cannot be decrypt the data and encrypt with a truly random quantum keys with the key itself. The unique in the real-time alerts, the unique properties of quantum mechanism ensure that any atoms often measure copy key during transmission. It will disturb its quantum states immediately alerting both partitions. And foundations of QKD networks, like these are the keys of the cornerstones of quantum key distribution networks, providing ultra secure communication channels for sensitive applications like banking, governments, and critical infrastructures. And real world progress and challenges, like in the current state, operational operational network, it will be already operational. There are several countries deployment in China and advanced trade across the European demonstration. It's practically feasible for secure communication over short to medium distance today. Future outlook, preparing for the quantum era, like while quantum computers capable of breaking current cryptography algorithm like RSC are not yet fully realized. Their development in progressing rapidly, and the immediate future involved hybrid cryptography are essential. Transfer traditional ways that combines robust classical encryptions with newly developed quantum resistant method. It will be create a dual layer of security for the user. And how QKD works, it means Alice and Bob, they are the two persons in this in this QKD works. One person is Alice and another person is Bob. And Alice sends transmit photons with random polarization state to the to a quantum channels, and Bob receives the incoming photons using randomly chosen measurement basis, and then it will be goes to the key generation, like Alice and Bob compare measurement bases publicly and keep matching result as a secret key. And then the final stage is if the Eve if the Eve intercept photons, quantum state collapse, creating detectable disturbance. Preparing the quantum ages, it will be classified as a three types, like post quantum cryptography, like and crypto agility, addressing store now, decrypt later, and research and developments are underway for the post quantum cryptography, and it will be also called as a PQC algorithm. For example, it will be also have some lattice based and code based with the quantum attacks, and cryptography, it will be have enabling them adapt and switch quickly to new quantum safe standards as they emerge and are formalized. Addressing store now decrypt data, and store now decrypt data thread decrypt by future quantum computers. The quantum future is secure. Mm, It will provide the unbreakable security grounded in the immutable law of physics, and also it will critical and it will also provides the critical to safeguard global digital infrastructures from the impending quantum threats, and also it is a revolution. It is not just an evolution. It is a and it is that will fundamentally refine how we receive and achieve digital security forever. and it is unbreakable security grounded in limitation and challenges, like distance and limitations. Current QKD system operation over optical fibers are typically short distance, like around 90 to 100 kilometers only, and high cost and complexity. It means it will infrastructure requires quantum cryptography including specification system proton and alignment system is expensive and complex to deploy and maintain, and scaling issues like building large-scale quantum networks with many interconnection nodes is a complex, and research into quantum operators is a trust node is a virtual to extension. Your data deserves quantum potential. Enhance the future. Invest wisely. Stay ahead. And embed quantum cryptography and quantum safe protocol into your security architecture today to safeguard your information for tomorrow. And the future of secure communication is quantum. Don't let your data to the face of this transformative technology shift. Real world implementation. And China measures satellite, world first quantum communication satellite, establishing quantum encrypted communication between Beijing and Vienna across 7,600 kilometers, providing a long distance QKD feasibility. European quantum networks and India's DRDO project, like developing of indigenous quantum communication links for defense application, focusing on secure military and strategic communications application across industry like banking and financials, military defense, healthcare, and governments. These sectors are majorly used by this topic. And the future of quantum cryptography is satellite QKD expansions, quantum repeaters, global quantum networks, and standardization effects like NIST, and it is organizations like National Institute of Standard and Technology and other global agencies are actively working to standardize quantum safe cryptography methods, ensuring the board adoption. In the quantum future, will reshape global security in the coming decades, offering unbreakable future-proof security that revolutes how we protect digital information, like 5G and IoT integrations and quantum internets, commercial deployments, career opportunities. Conclusion: Quantum cryptography's promise. What are the promises? Quantum cryptography represents a fundamental shift in how we approach cybersecurity. It moves use beyond relying on computational assumption on relying the laws of physics, offering a truly robust defense against the most threats. The new era of unhackable communications are in the age in an age where data breaches and cyber threats are increasing common. Quantum cryptography offers a path to information theoretically security, ensuring that our most valuable communication remains private and protected. The quantum security revolution is not distant dream. It is already underway with research, acceleration, and early commercial deployments emerging. Are you ready to embrace the transformative technology and sure and secure your future communication? Thank you.